In this video, we're going to look at solving a logarithmic equation. So here I have a log in my equation, so I know it's a logarithmic equation. And this one is kind of a traditional one. I only have one logarithm and I have a bunch of other different numbers. So when I see one like this, my first thought is I just need to isolate my x. So the only problem is that my x is inside of a logarithm. So more specifically, we're actually going to isolate the log. Once again, we're using SADMAP, which is that backwards order of operations. So I'm going to see, is there anything that I can add or subtract to the other side? Oh, I can add an 8 to the other side. So now I have 2 times the log base 2 of x minus 1 equals, well, that's 6. Now, something that a lot of people like to do, and we're going to do this in red because we do not want to do this. A lot of people recognize that we could use the power rule and move this here to become an exponent and to rewrite this as the log base 2 of x minus 1 squared equals 6. Whereas this is technically a mathematical true statement, it's not a useful step because it's not allowing us to get x by itself. We are trying to remove numbers and we're trying to move them to the other side. So I do not want to do that. Instead, the operation between 2 and this logarithm is multiplication. So I'm going to just divide it to the other side. Now I have the log base 2 of x minus 1 equals 3. I've successfully isolated my logarithm. So now I have to get rid of my logarithm. And once again, there are a handful of different ways that you can do this, but the way that I have found it the best is to what I call exponentiate both sides. Exponentiate. And you might be like, what in the world does that mean? And I'm about to show you. We're going to use the property that if you have some base and its exponent is a log with the same base, this side just simplifies down to whatever that argument was. That is the property we're going to do. And one of the really cool things with math is that you can do anything to one side of the equation as long as you do it to the other. So we are going to exponentiate both sides. Use the base of your log. We always want to keep a common base because here we have b and we have b. So what that means is we're actually going to rewrite this. I'm going to move my 3 over just a little bit so we can see this. We are going to turn these into the exponents on both sides. And because my base is 2, we are going to use a base of 2. So this becomes 2 to the log base 2 of x minus 1 is equal to 2 to the cube. Why we did that is because we can now see this has the same base, this has the same base. When that happens, once again, this pretty much cancels each other out, leaving me with x minus 1 equals 2 cubed. So kind of my next step underneath this, once again, kind of a step like 2.5 would be simplify the side with the log. And we're using this property, once again, right here, that if your base of your exponent and the base of your log are the same, this just simplifies down to what was your argument. So this entire side simplifies over to x minus 1. Also underneath let's make it 2.75, we need to actually evaluate the exponent. So here I have 2 cubed. I need to actually evaluate that. So if x minus 1 equals 8, we're super close to being done. One of our final steps is just going to be, so step 3, all of these went hand in hand together. They're all part of the same process. So once again, exponentiating both sides, simplifying and evaluating, those all go together. Now we're actually just able to isolate x using SADMAP again. So I'm just going to add 1 to the other side, and I get x equals 9. This one, however, my original equation is a logarithm. And that means that the last thing we have to do is check that your argument is positive. So we know that one of the constraints on all logarithms is that the argument must be a positive number. So this answer only works if I plug it in and my argument is negative. So my argument is x minus 1. I'm going to plug this in. 9 minus 1 Well, that's going to give me 8. That is a positive number. Now give me a little smiley face. That means it does work. This is my final solution. So whenever you have a logarithm in your original equation, you do always have to go back and check that the solution you got will keep your argument positive. If it doesn't, we just cross it out and it's no longer a solution.